Hi and hello to everyone. In this video, we are going to see the Z transform. Okay, Z transform is used for analyzing or working with discrete time signal or discrete time system. We will be seeing the definition of Z transform and where the Z transform is used in signals and system perspective, and what about the region of convergence and importance of region of convergence in Z transform, and we will be deriving the Z transform of few basic signals. Welcome to the lecture. So this is the definition of Z transform. Z transform converts x of n, that's your discrete time domain signal, to capital X of Z. This is your Z domain signal, right? So if I have a signal in time domain, a discrete time domain x of n, I can convert it to Z domain capital X of Z by using this relation. Summation n equal to minus infinite to plus infinite x of n Z power minus n. It's an infinite series. It's an infinite series because n is from minus infinite to plus infinite. What about the inverse Z transform? Inverse Z transform converts from Z domain to time domain. So I have a capital X of Z. I will be converting that into small x of n. That is the discrete time domain. I will be using this relation. But mathematically, in max, you will be using this relation to take the inverse Laplace inverse Z transform. But here in signals and system, we will be using Z transform pair to convert from Z domain to time domain or discrete time domain. Okay, we will not be using this relation. Okay, in mathematics, you will be using this relation. Okay, right. Our objective is to, in this video, we will be seeing only the Z transform. Is inverse Z transform, I will be explaining in the next video. So these are the few applications of Z transform from signals and system point of view. So it converts a difference equation into algebraic equation, right? Any system, I will be in discrete time system, I will be using difference equation. Difference equation will be in the form of time in the time domain. I will be converting that into algebraic equation. We know solving algebraic equation is very much easier when compared with working with difference equation. Then I can do convolution is very much easier in using Z transform in a discrete time domain. Similarly, to finding the various responses. Various responses means impulse response, step response. All those responses are easier while we work with Z transform than working with straight away in discrete time domain. Those are the advantages. As I said earlier, the Laplace transform is only a temporary, right? We'll be from time domain, we'll be converting into Z transform, we'll be working there, then convert the Z transform back to time domain by taking inverse Z transform. So temporarily only we will be in the Z transform domain. Okay, this is the Z plane. If you ask what is Z, Z is R e power j omega. We know in polar form, we know this is the magnitude R e power j theta. So theta, this theta, in place of theta, I have put the omega. So R is the magnitude, omega is the angle. So if you take, this is the polar plane, or I can say this is the Z plane. Here I will be using the word Z plane. Z plane. So this axis is real part of Z. This axis is imaginary part of Z. Okay. I can expand this, right? So what about here? Real part of Z, e power j theta, e j omega is cos omega plus j sin omega is equal to r cos omega plus j r sin omega. So this axis is r sin omega, this axis is r cos omega. Or else in polar form, we know we will be using the magnitude. These are the radial lines represent the magnitude, and the angle. This is the 0 degree, 90, 180, 270 degree. Angle will be in anti-clockwise direction. Okay, so R is the radius of the circle, center of the origin. I can say the magnitude, or simply I can say radius of the circle. If this circle is R, from here to here it is R, from here to here it is R, here to here it is R, right? Only difference is R is same. R can take so many values along the radius. The difference is omega. Here I can say this omega is between 0 and 45. This omega here, it is between 0 and 270. This omega is between 180 and 270. This R is at 0 degree. Right? Okay. We know the magnitude. What is the magnitude of Z? Magnitude of Z is equal to magnitude of R and magnitude of e power j omega. What is the magnitude of e power j omega? It is cos omega plus j sin omega. Magnitude cos square omega plus sin square omega. So this term is 1. This term is 1. So magnitude of z means is nothing but magnitude of r. Right? That is why r is said as magnitude. Okay, this is about the z plane. So z plane is nothing but we have the magnitude and angle. We will be interested while taking the magnitude. We are interested only in the r. We are not worried about the omega. Okay, because omega can take any values, but r is a circle. That's why I said r is a radius of a circle centered at origin. Okay, we'll work out a problem. This is the first very important basic problem in the transform. I have taken an x of n is equal to u of n. What is u of n? U of n is a unit step signal in discrete time domain. Okay, so this is a discrete time domain. So n is an integer 0, 1, 2, 3 going up to infinite. For positive values of n only it is 1. For negative values of n, for example, n is minus 1, minus 2. For those values it is 0. It is 0. So such signals is this signal is called unit step signal in discrete time domain, right? So as I said, this is the definition of Z transform. N is from minus infinite to infinite, and we know u of n is 1. Amplitude is 1 only for n is equal to positive values. Okay, so instead of minus infinite to infinite, taken from 0 to infinite, z power minus n. So I can write it as z power minus 1 whole power n. Okay, and we know we are going to put n value 0 to infinite. So this is keep on going. Z power minus 1 power 0 plus z power minus 1 power 1 plus z power minus 1 power 2 plus z power minus 1 power 3. We keep on going up to z power minus 1 power infinite. It is an infinite series. And we know from our basic maths that geometric progression of an infinite length, if it is from 0 to infinite a power n, I can write this as 1 by 1 minus a, provided the condition is very very important. This a should be less than 1. This a should be less than 1. Okay, so you know this relation. I can write this infinite summation, infinite length summation as 1 by 1 minus a, provided the condition should be this a. This a should be less than 1. Right? Similarly, I can write this as, this is taken as a, 1 by 1 minus a. So this term should be, that is the ROC, the condition is magnitude of a should be less than 1. Instead of a here it is z power minus 1. Okay, should be less than 1. So z power minus 1 I can write 1 by z, taking z this side. So magnitude of z should be less than 1. Sorry, magnitude of z should be greater than 1 because z is going this side, right, to the right side. Okay, now we will be writing in some other form. So this is also an answer. If what is x of z, I can stop here also along with the ROC. Okay, magnitude of z is greater than 1. Or else I can write in another form, z power minus 1 I can write 1 by z, then taking the LCM z by z minus 1, bringing the z to the numerator, I can write it like this also. This is also an correct answer. Some books follow this convention, 1 by z 1 by 1 minus z power minus 1. Most books have z by z minus 1. It's up to you. Okay, you can write this or this. Remember, both are same. Right? Then I have written the result is greater than 1. Magnitude of z is greater than 1. So as I said earlier, so if this is the z plane. So this is your real part of z. This is your imaginary part of z. So if this is the unit circle, what is the ROC? Z should be greater than 1. Z should be greater than 1 means that is why these blue color radial lines are greater than 1. So this is the ROC diagram. This is also very important. Okay. Next problem. I have taken a power n u of n. Right. Again, u of n means I have taken from 0 to infinite. I have ignored the n negative terms. Right. So a and z power minus 1 together I have multiplied, taken n outside. So this is your total a. It's an infinite series. So this is total a. I can write 1 by 1 minus a. Okay, so this is your a. You know geometry progression relation in the previous slide. Using that I have written 1 by 1 minus a. Right. This I can write as, provided this term should be less than 1. That ROC, this term should be less than 1. So a by z is less than 1. Z should be magnitude of z should be greater than a. Okay, so what is Z transform of a power n u of n is Z by Z minus a, or 1 by 1 minus a into Z power minus 1. ROC is greater than a. So if this is a, ROC this is the radius of a, the circle. ROC is greater than a. That is the condition, right? Now we move into the third problem. The third problem, I have taken these values. Okay, u of minus 1 minus 1, u of minus n minus 1, right? This is nothing but n should be negative value. N should be negative values, right? If you put n is equal to minus 1, I will get 0 inside, positive value inside. If I put n as minus 2, I will get positive values inside. N as minus 3, I get positive values. You know n inside the bracket, if the positive value only, the answer is 1. Okay, so this summation from minus infinite to plus infinite can be changed only for negative values, for u of minus n minus 1. Okay, so and I change it from see minus infinite to plus infinite. If I'm going to add, I can change it from minus 1 to minus infinite to minus 1. If I'm going to add, I can change the order. So minus 1 to minus infinite. Okay, next, see it's n is minus values, right? Here it is minus n. Can I make this as plus n and change it to plus values? The meaning is the same. If I'm going to substitute n as negative, if you're going to substitute n as negative, already negative is the negative to negative positive. So I can make this as positive, as well as I can change this to positive values. Okay, I'm changing. In place of n, I'm going to put minus n. That's why this has become positive. In place of n, I'm putting minus n. So this has become negative, has become positive. Okay. Now what I'm doing is, it is from 1 to infinite. We know geometry progression should be 0 to infinite. Okay, further what I'm doing is I'm adding 1 and subtracting 1. Right? If I'm subtracting 1, I'm bringing this minus 1 inside and I'm making it as 0 to infinite. Right? It is from 1 to infinite. If you put n equal to 0, what happens? If I put n equal to 0, it becomes z power 0 is 1. Z power 0 is 1, so minus is there, minus 1. So this minus 1 can be brought inside the summation and change the limit from 1 to infinite to 0 to infinite. Okay, this 1 is brought inside the summation itself. Okay, this is why I have written is, we know the geometry progression relation is from 0 to infinite only we know. So this is geometry progression relation, z power n. So we know a power n means 1 by 1 minus a. A should be less than 1. Instead of a, here it is z. So 1 by 1 minus z. ROC is z should be less than 1. Then other things like simple mathematical manipulations, right? We are putting like this, we are getting this, we are getting z by z minus 1. Okay, so what is the ROC? Z should be less than 1. So this is the 1 unit circle, ROC is inside the circle. Remember, for u of n, Z transform is Z by Z minus 1. Sorry, it's not u power n, it's u of n. And u of minus n minus 1, Z transform is, for this also, see, I put minus here, right? If there is no minus here, there is no minus here, here the minus should be coming in the right side. Keep in mind, right? Both are positive like this. For the negative values of n, this sort of question, right? Now for u of n is negative means, here if it is minus means it is plus, here it is plus means here you should put minus. See, u of n is a transform is like this, u minus u of minus n minus 1 is a transform is this. Only difference is for this, the ROC is magnitude of z should be greater than 1. For this, the ROC is magnitude of z is less than 1. Magnitude of z is less than 1. That should be very clear. Such signal, these signals we can say u of n is causal. For positive values means causal, positive values of n. For negative values of n means non-causal. Non-causal, or simply I can say anti-causal. That's the correct word. Because only for negative value. For both positive and negative means we can say non-causal. Okay. For positive values of n, for causal signal is greater than 1. For anti-causal signal it is less than 1. But the z transform is the same. U of n, it is z by z minus 1 minus u of minus u of minus n minus 1. Z transform is z by z minus 1. That you have to keep in mind. Okay, so if you write ROC only, the answer is correct. Without ROC, it's not a correct answer. Okay, next is minus b power n u of minus n minus 1. Okay, and we know for these values already I have discussed, inside the bracket it should be positive value, so n should be negative, then only we get positive value, then only u of inside the bracket positive value only is 1. Okay, so from minus infinity to minus 1, I am changing from minus 1 to minus infinity, nothing wrong. So I can write b power n z power minus n. I am going to change from the n limit from minus infinity to plus infinity to 1 to infinite. So n I am going to multiply with minus 1. So if this n is multiplied with minus 1, so minus 1 has become plus 1, minus infinite has become plus infinite, and similarly this n has become minus n, this minus n has become plus n. Okay, right. Now you take n commonly outside, right? B power minus 1 z power whole power n. I can write it like this. Okay, taking n outside. Okay, and again, what is that? Is from 1 to infinite. I have to make it to 0 to infinite. So what I'm doing is I'm adding 1 and subtracting 1. Bringing this minus 1 inside, I can compensate by adding 0. Okay, so this is your what progression? Geometric progression. This is your a term. So 1 by 1 minus a, provided this term b power minus 1 into z should be less than 1. B power minus 1 z should be less than 1. So that is nothing but z by b should be less than 1. So magnitude of z should be less than magnitude of b. So this is the ROC. Okay, other things are simple mathematical manipulation, taking it to the numerator this side, taking the LCM and proceeding, we will be getting this. Okay, so the z transform of minus b power n u of minus n minus 1 is z by z minus b. ROC is magnitude of z should be less than b. Okay, now we look at this problem. A power n u of n minus b power n u of minus n minus 1. So this is your, let me say, this is simply going to use the property, straight away not going to solve. I'm using linearity property, that is I can process the signal part by part. So this part I am solving separately, this part I am solving separately, taking the z transform, then ultimately I am adding. Okay, so this is x1 of n, this is x2 of n. What is the x1 of n z transform? x1 of z, x2 of n z transform, x2 of z. What is the transform of a power n u of n? z by z minus a. So minus b power n u of minus n minus 1 is z by z minus b. Okay, for this the ROC is, it's a causal signal. Causal signal is greater than a. This is negative values of n, so it is an anti-causal signal. So it is less than b. Okay, this is individually. Together, when they are combined, it should be having a common ROC. What is common ROC? If you look at this diagram, this circle is a, this circle is b. Okay, right? So if I say for this, it is greater than a. I will write roughly here. So this is a. Greater than a means it is like this. This is for the first part. What about the second part? Let me say this is b. Not b should be greater than a. Then only I can rule like this. If it is not, it's we cannot have z transform. Okay, b. For the second condition, z should be, magnitude of z should be less than b. I will use some other color, green color. So this is the b circle. This is the b circle of radius b. Circle of radius b. It should be inside that, right? So can you find which region is common? Common region is between A and B. This region is common. Between, you can see red color strip line and the green color strip line is common in this region. Okay, that is what I have mentioned here. ROC is between A and B. So this is the answer. This is the corresponding ROC. Okay, by using linearity property, I have solved it. Right? This is nothing but a finite sequence, right? Finite duration. We can see x of n is not infinite, it is finite. It is from 0, 1, 2, 3, 4, 5. X of 0, x of 1, because this arrow indicates x of 0 position. This is x of 1, x of 2, x of 3, x of 4. This is x of 5. Okay, it's a finite duration for positive values. So finite causal sequence. For a finite causal sequence, what I can do, we know Z transform is an infinite series, but here x of n is existing only for what values? N should be 0 to 5. So I am changing the limit to 0 to 5 and I am substituting x of n in place of n I am putting 0. So Z power 0 is 1, x of 1 Z power minus 1, x of 2 in place of n I am putting 2 Z power minus 2, then plus x of 3 in place of n I am putting 3, x of 4 Z power minus 4, x of 5 Z power minus 5. Okay, now substitute the values of x0, x1, x2, x3, x4, x5 in this expression. Okay, z power minus 1 I can write 1 by z, z power minus 2 is 1 by z square, z power minus 3 is 1 by z cube, z power minus 5 is 1 by z power 5. Right, so what is the ROC? ROC is nothing but x of z should be finite. Okay, see, whatever values of z I put, it will be finite, but I should not put z as, except z as 0. Okay, it should be not infinite, except z as 0. If I put z value 0 here, 1 by 0, anything by 0 it becomes infinite. So I can use whatever values of z. So all values of z, ROC is all values of z except z equal to 0. So this is the for a finite causal sequence, this is the ROC. We will be seeing this in properties also. Okay, remember that here I am explaining ROC for a finite causal sequence. For causal sequence means only for positive values of n. It is finite because only 6 values of n are there. All are positive values. So ROC is all values of z except z equal to 0. Okay, right. Now we will see. If you look at this arrow is here. So this is x of 0. This is x of minus 1 left side. Okay, because this arrow is 0 means left side it is negative values. This is x of minus 3. So this is finite anti-causal sequence because only for negative values it is existing. Right? So it's an infinite series. Okay, what are the n values? 0, minus 1, minus 2, minus 3. So it is from n value is 0, minus 1, minus 2, minus 3. So substitute first minus 3. X of minus 3 in place of n, if I substitute minus 3, minus minus plus. X of minus 2 in n I am substituting minus 2, minus into minus plus. So z square. In place of n I am going to put minus 1. So x of minus 1 is a power minus of minus 1. It is z power 1. Then substitute n as 0. Z power 0 is 1. Okay, right. Now you substitute the values of this x of minus 3, x of minus 2, x of minus 1, x of 0. See, I am identifying the 0th position by this arrow. Okay, the arrow is not given, we will be taking this as the 0. If the arrow is given, this is 0, this is minus 1. This side the values that mean they are the positive values. Okay, right. So this is the, if we substitute these x of minus 3, x of minus 2, x of minus 1, x of 0 values, I will get the Z transform. So this is the Z transform of this. What about the ROC? See, Z can take any values. Even you can put 0 also. If you put 0 also, the answer is 1. Right? It is always finite. But if I put Z as infinite, infinite plus infinite is anything is infinite. So ROC is all values of Z. I should not use Z as infinite except Z equal to infinite. So the another property of ROC for a finite anti-causal sequence. Another name for anti-causal is left-sided, because you can see the signal is for only negative time. Some books use left-sided sequence. Okay. Similarly, in the last slide, for a causal sequence means some books use right-sided sequence, because for positive value we can see it is from 0, it is from the right side, it is increasing. Time is increasing the right side. Right-sided sequence. Okay. Now we move to the same this problem. Solve the problem. See, for a finite anti-causal left-sided sequence, ROC is all values of z except z equal to infinite. I should not use z values as infinite. Okay. Now this is the another problem. It is both-sided sequence. See, this is your x of 0. This side is positive, so x of 1. This is x of 2. This is x of minus 1. This is x of minus 2. This is x of minus 3. Okay, so this is, I can say, non-causal. Non-causal means for both positive and negative time. Finite non-causal sequence. Finite non-causal signal, or else I can say both-sided signal. Both-sided signal or both-sided sequence, because it is both in the right side and left side. Since for right positive time, negative time, I am using only non-causal. If it is only positive, causal. Only negative means anti-causal. For both the positive and negative means non-causal. It is finite because how many time samples are there? Minus 3, minus 2, minus 1, 0, 1 and 2. Only 6 samples are there. So it is a finite sequence, right? Now I can expand this. I have seen so many times. N is from minus 3, minus 2, minus 1, 0, 1, minus 2. Put those values in the transform, we get this expression. Now put these values here, corresponding values there, right? So this is a transform. What about the ROC? See, it is 1 by z. 1 by z, if I put z as 0, this becomes infinite. If 3z square, if I put z infinite here, this entire term becomes infinite. So for all values of z, I should not use except z equal to 0 and z equal to infinite. If these two are avoided, these two conditions are avoided, then x of z is converging or finite. If I use x as 0, z as 0 or z as infinite, then this will become infinite. Okay, so ROC, region of convergence, is all values of z except z equal to 0 and z equal to infinite. So this is for a finite non-causal sequence. This is the ROC. Next, we will be seeing about the sine, another important signal, sine omega naught n, discrete time sinusoidal signal u of n. Okay, since it is this is the definition of Z transform. In x of n, I'm substituting. You have u of n. U of n is for only positive values. It is 1. So I'm removing the negative terms of n. So I'm putting 0 to infinite. Sine theta I can write as e power j theta minus e power minus j theta by 2j. So instead of theta here it is omega naught n. So e power j omega naught n minus e power minus j omega naught by 2j. Okay, other things like I am splitting this into two summations, bringing z power minus 1, 1 by 2j I have taken outside since it is a constant, I am taking outside. Okay, two summations I have split. Okay, this term separately and this term separately, along with z power minus n, I have brought it inside. Okay, right. So if you see this, what about this? This is a power n, z power minus n. Am I right? This is a. I can say this term as a. Okay, what is the transform? We have seen already. Z by z minus a. Here, what is a? This is a. So, z by z minus e power minus j omega naught. Remember, it is plus j omega naught here. Here it is minus j omega naught. Okay, even you can solve this, right? But I am using the relation and solving, getting this answer. We have derived a power n u of n. Instead of a, here this term is there. So, the answer would be like this. Okay. So I am taking the LCM, that is I am multiplying these two and cross multiplying. Okay, other things you can see, taking z outside, this z square will cancel, taking z outside, I give this in the denominator also. From these two terms I am taking the z outside. Okay, get this. This you can pause the video and you can take the notes. It will be simple thing, simple max, elementary max. Okay, so e power j theta minus e power minus j theta is 2j sin theta. Right, so instead of theta here it is omega naught. Similarly I can write e power minus j theta plus e power j theta as 2 cos theta. So here instead of cos theta here it is omega naught. This comes here. So if this 2j will get cancelled out. Okay, so what is remaining? Yes, here important point, right? I won't forget that. I can go into that. Yes, if it is z by z minus a, what is the ROC will be writing? Can you recollect? ROC is Z by Z minus A means we'll be saying magnitude of Z. If it is a causal signal, right? Because U of n is the causal signal, Z by Z minus A. Here instead of A, what is there? E power j omega naught is there. What is the magnitude of e power j omega naught? We have seen already, it is 1. Because e power j omega naught is nothing but cos omega naught plus j sin omega naught. Magnitude is square root of cos square omega naught plus sin square omega. Cos square plus sin square is 1. Okay. Similarly, what about this ROC? Here, it is should be greater than e power magnitude of e power minus j omega naught. This is also 1, greater than 1. Okay. So for this term, ROC is greater than 1. For this term, greater than 1. Together, the common region is greater than 1. That's what I have mentioned here. ROC e power plus or minus. Together, we can write. Okay, that is greater than 1. So we got this. So this is the answer for. I think we started with sin omega naught n u of n. So this is the Z transform. R is greater than 1. We can write in different form. Okay, divide numerator and denominator by Z square. I get this. So Z and Z square gets cancelled. One time cancel. So Z coming to the numerator is Z power minus 1. So Z square cancel 1. So Z and Z square one time cancelled. One Z is cancelled. So numerator is coming as Z power minus 1. 1 by Z square is Z power minus 2. Both are correct answer. This is also a correct answer. This is also a correct answer. Both are approximately the same thing, but different format. Right? ROC is greater than 1. So if you look at this, say ROC is greater than 1, this is the unit circle. So these red lines indicates outer than greater than 1 or outside 1. Okay. Now I request you to solve cos omega naught n. The answer is this. Answer is this. Again, ROC is greater than 1. For this, I give a hint. Cos omega naught n can be written as e power j omega naught n plus e power minus j omega naught n by 2. Using this relation, refer the 9th problem example and try to work it on your own. If you are getting the answer, put in the comment section that I got the answer for this 10th problem. You should get this answer and this ROC. Try on your own. Okay, then we move to the 11th problem. 3 into 3 power n minus 4 into 2 power n u of n. So bring u of n inside. Okay, again it's using linearity property. I can take Laplace transform of 3 power n u of n is this, 2 power n u of n is this. For this, the ROC is, since it is a causal sequence u of n, ROC is greater than 3. For this, is greater than 2. So if you look at this, greater than 2 means these red lines. Greater than 3 means these blue strip lines. Okay, blue radial lines. Okay, blue radial lines are going outside. So what is the common region? Common region is, I am asking, what is common between these red lines, these red radial lines and blue radial lines? It is this region. It is this region. The region means, what is the meaning? It is greater than 3. Okay, so the final ROC is greater than 3. This is imaginary part of Z. This is real part of Z. Okay, so this is the final answer. Okay, this is for your understanding. I have drawn both. Finally, the answer is greater. ROC is greater than 3. I have to take what is common between these two conditions. This says the greater than 3. This says the greater than 2. So what is common? Greater than 2 means this entire thing. Greater than 3 means this entire thing. Common region is greater than 3, which is common to both. Okay. Right. Next, we can see this. This is what signal? This is a, I can say this is anti-causal signal, because n is for only negative values. Negative values of n only this is going to work, right? Okay, so anti-causal sequence. So here it is you know this minus sign is not there, so I'm putting minus here. Z by Z minus 2. Here it is minus is there, so I'm putting plus Z by Z minus 3. Already we have seen this. Okay, since it is an anti-causal sequence, ROC is less than 2. If it is causal, greater than 2. If it is U of n, we would have put greater than 2. Here we have put less than n, U of minus n minus 1. So ROC is less than 2. For this, it is less than 3. So I'm using two circles. This red circle radius is 2, green circle radius is 3. For the first condition, less than 2, it is inside. For the second condition, less than 3, it is the green lines, which is also inside. Okay, so what is common between these two? Sir, for this it is less than 3, it is inside. For 2, it is less than, for 2, it is inside, right? Inside 2, for 3, it is inside 3. The common region is less than 2. ROC, magnitude of Z is less than 2. So this is the final answer. Okay. We have another problem. This is what signal? Yes, I hope you guessed it. This is U of n. This is a causal. U of minus n minus 1. This is non-causal. Okay. For causal, it is Z by Z minus 2. This is also minus is there, so I'm putting plus Z by Z minus 3. Since it is causal, it is greater than 2. For this, it is less than 3. Okay, for causal signal it is greater than 2. For the non-causal signal it is less than 3. Right? So what about the conditions? Try to plot. So this is 2. This circle is 2. Then is some other color. This circle, blue circle radius is 3. Okay. What does first condition say? First condition say that it is greater than 2. Second condition say that, second condition say it is less than 3. Less than 3 means it is inside 3. Can you identify a region which is common to both? Common to both means where the red lines and green lines are there, it is between 2 and 3. So the common region is, common region or the ROC of the given question is Z should be greater than 2 and less than 3. So this is the final answer. So this is your X of Z. These are the final answers. This is for your convenience or understanding purpose. Separately I have drawn. Separately I have given. Separately I have drawn. Okay. So the final drawing would be like this. It will be between if this is 2, radius 2, this is 3. ROC will be here. I'm sketching it for you, right? I think it's good now. Between 2 and 3. Okay. You have to mark it, right? Don't forget to mark the real part of Z, imaginary part of Z, center origin is 0. These things you have to make. Okay. Here it is minus imaginary part of Z. Here it is minus real part of Z. Left side. This is minus real part of Z. This is minus imaginary part of Z. Okay, what about this? 2 power n, U of minus n minus 1. For this, I can write X transform as it is a left-sided or a non-causal sequence. So it is plus is there, so I am putting minus here. Z by Z minus 2. So this is 2. Okay, right? For this, it is a causal sequence. So it is Z by Z minus 3. Okay, what is ROC? Since this is non-causal, so negative values of n. So ROC is Z less than 2. For this, it is a causal sequence. So ROC is greater than 3. Okay, so if you're going to plot, this is 2 radius, this is 3 radius circle, right? 2 circles are there. What does first condition say? This condition says it is inside the circle. What does second condition say? Greater than 3. outside the circle. Do we have any common region? No common region. So no ROC. So we don't have, very important, we don't have Z transform. No Z transform. No Z transform for this question, because there is no common ROC. Individually, if this is asked, this is the Z transform, this is the ROC. If this is separately asked, this is the Z transform, this is the ROC. They are combining, there is no common region, so doesn't have any, they don't have any Z transform. So you cannot say blindly, you cannot solve this, right? I cannot say this is X of Z. No. Based on the ROC only, I can conclude ROC is essential for the Z transform to exist, because ROC is nothing but region of convergence. This question will not converge. It's always an infinite. Okay. There is no common region for this and this sequence. This and this sequence. So there is no Z transform for this question. Okay, keep in mind. Okay, now we'll see the properties. Right? We are seeing the examples. Now we will be very interested to see the properties. Right? ROC is a ring or disk in the Z plane centered at the origin. We can say ROC is a ring. If you look at the previous problem, ROC is a ring. Okay, or ROC is a disk. Okay, both words I can use in the Z plane centered at the origin. And if you take ROC, it does not contain any poles. Okay, it will be inside the lowermost pole or greater than the largest pole. It will not contain any poles. And we have seen for a finite causal sequence, it is except the entire Z plane except Z equal to 0. We will look at all three, then we will go to the previous examples. For a finite anti-causal sequence, except Z equal to infinite, ROC. For a two-sided sequence, except Z equal to 0 and infinite. These examples already we have seen. Yes, so this is a causal sequence. ROC is all values of Z except Z equal to 0. This is anti-causal sequence or left-sided sequence. All values of Z, ROC is except Z equal to infinite. For this is a non-causal sequence. And finite, we also call both-sided sequence. All values of Z except Z equal to infinite. 0 and except Z equal to 0 and infinite. Okay. Two sides nothing but non-causal sequence. This 3, 4, 5 property has been explained. Now come to 6th property. For an infinite causal sequence is outside the outermost pole. For infinite anti-causal sequence inside the innermost pole. For an ROC of infinite two-sided sequence, a ring in the Z plane. We'll see these 3 examples. Okay, what about this? This is a causal sequence. What are the poles? Poles are the denominator. If I equate, these are the poles. Z equal to 3, Z equal to 2. Okay, Z equal to 3, Z equal to 2 are the poles. You can see these are the poles. Z equal to 2, this circle is a pole, this circle is another pole. Z equal to 3 is another pole. Okay. What is the ROC? It is greater than 3. So, this is an infinite sequence. This is an infinite causal sequence. Infinite causal sequence. ROC is greater than the largest pole. Greater than the largest pole. What is the largest pole? 2 or 3? 3 is the largest one. So ROC is greater than 3. This is one property. Okay. If you look at this, this is an anti-causal sequence. Anti-causal sequence. Anti-causal sequence means it is left-sided. Okay. So it is less than 2, less than 3. What is ROC? Less than 3. So it is inside the smallest pole. If 2 or 3, which is the smallest? 2. ROC is inside the smallest pole. Okay. Look at the next one. It is both sided. U of n is causal. U of minus n minus 1 is anti-causal. Together it becomes non-causal. Okay, for this it is greater than 2, for this it is less than 3. It is between 2 and 3. Okay, these properties are what explained here, right? For a causal sequence, it is outside the outermost pole. For an anti-causal sequence, it is inside the innermost pole. For a two-sided sequence, it is a ring in the Z plane between two poles. Okay, then very last point, for a stable system, it should include the unit circle. ROC should include the unit circle, right? We'll look at the ninth. See, let me represent the system using Z transform. H of Z is system in Z transform. We are having Z by 2 Z by no, not 2, 2 like, okay, fine. 4 Z by Z minus 0.2 Z minus 0.3. Okay. Where are the poles? This is 0.2. This is 0.3. This is a circle. This is a 0.3 circle. Okay. Where is 1? Unit 1. 1 is here. This is 1. Where are the poles? Poles are inside the unit circle. Poles are inside the unit circle, and ROC should be outside 3, outside 0.3. Okay, this is the ninth property, right? This is 0.3, this circle is 0.3, 0.2, this circle is 0.3, this is unit circle. If all the poles are inside the circle, all the poles are inside the circle. What are the poles? Denominator, if I equate to 0, I will get the poles. Okay, I get the poles. Then the ROC is, if the ROC is greater than 0.3, it is touching the unit circle. It is touching the unit circle. Then it is here. Then this system is stable system. Then this H of Z is stable. Suppose if H of Z is Z by Z minus 2 and Z minus 4. Where are the poles? Pole is at 2, pole is at 4. So this is one circle, this is another circle. Here inside we have the unit circle. Okay, so if the ROC is going away or outside 4, then it is not touching 1. So this is this H of Z is an unstable system. Okay, that's the property, that's a ninth property. Must include, ROC of a stable system must include unit circle. Here this ROC is including the unit circle, but for this ROC is 1 is here, 2 is here, 3, this is a 4. It is outside 4, so it is not including unit circle. So this H of Z is unstable. Okay, right? Then okay, in the next video we will be discussing on the Z transform properties and other things like how to do convolution easily using Z transform for a discrete time signal and finding out the response of discrete time system for various inputs. I hope you learned something useful from this lecture. Please take notes while listening. Any doubts, please put in the comment section. If you like, please give thumbs up. Do share your videos and discuss with your friends. Thanks for listening again. Jai Hind.